Ever noticed how your seatbelt slides out smoothly when you pull it slowly, but locks instantly the moment you pull it too fast? It almost feels like the seatbelt knows something dangerous is happening. But here is the clever part. Most of the time, it is not using a computer to think, it is using physics. Today on Knowledge Hub, we are looking inside one of the most important safety devices in your car, the seatbelt, and how it locks in a fraction of a second when you need it the most. A normal seatbelt is built around a part called the retractor, usually hidden inside the side pillar of the car. Inside that retractor, the belt webbing is wrapped around a rotating spool, and a spring gently pulls the belt back in when you release it. That is why you can pull the belt out, buckle it, move around slightly, and still feel comfortable. During normal driving, the spool rotates freely, letting the belt extend and retract smoothly. But hidden inside this small mechanism is a locking system, usually based on a ratchet wheel and a pawl. Think of a ratchet wheel like a gear with sharp teeth, and the pawl like a small metal finger that can drop into those teeth. When the pawl is out of the way, the spool spins freely. But when the pawl snaps into the ratchet, the spool cannot rotate anymore, and the belt becomes locked. So the real question is, what makes the pawl move at exactly the right moment? There are two main triggers. The first is webbing-sensitive locking. This reacts when the belt is pulled out too quickly. If you lean forward slowly, the spool turns gently. But if your body suddenly moves forward in a crash, or if you yank the belt sharply, the spool accelerates very fast. Inside the retractor, an inertia wheel or similar rotating mass resists that sudden change because of inertia. That tiny delay creates relative movement inside the mechanism, which trips the locking pawl into the ratchet wheel. In simple words, the belt does not need to know you are in danger. It only needs to detect that the belt is being pulled out faster than normal. The second trigger is vehicle-sensitive locking. This reacts to the movement of the car itself. Many retractors use a small pendulum, pawl, or inertia sensor inside the mechanism. During normal driving, it stays balanced. But when the car brakes hard, crashes, tilts, or suddenly changes direction, that small mass shifts position. When it moves, it triggers the same locking mechanism, pushing the pawl into the ratchet and stopping the spool. This is why a seatbelt can lock even before you pull it hard, because the car's sudden deceleration can activate the retractor first. And this is what makes the system so reliable. It uses the same physics that throws your body forward in a crash to lock the belt before your body travels too far. But modern seatbelts do not stop there. In many cars, the seatbelt is also connected to a pretensioner. This is a crash-activated device that tightens the belt almost instantly, and the vehicle detects the serious collision. Some pretensioners use a small pyrotechnic charge, similar in concept to the fast gas-generating system used in airbags. When triggered, it rapidly rotates the retractor spool or pulls the buckle downward, removing slack from the belt and holding your body firmly against the seat. This matters because even a few centimeters of loose belt can allow your body to move too far forward before the belt starts protecting you. Then comes another clever feature, the load limiter. Once the belt has locked and your body is being restrained, the force on your chest can become very high. A load limiter allows a small, controlled amount of belt to release when the force crosses a certain level. So instead of stopping your body with a harsh, rigid impact, the belt manages the energy more gradually. This helps reduce injury risk while still keeping you in position for the airbags to work properly. So a seatbelt is not just a strip of fabric, it is a carefully engineered safety system made of high-strength webbing, a spring-loaded spool, inertia sensors, ratchets, pawls, pretensioners, and load limiters, all working together in milliseconds. When you move normally, it gives you comfort. When the belt is pulled too fast, it locks. When the car suddenly slows down, it locks. When a serious crash happens, the pretensioner tightens it. And when the force gets too high, the load limiter helps manage that force. That is the beauty of it. Your seatbelt does not need to predict the future. It simply reacts to sudden motion faster than you can. So the next time your seatbelt locks, when you pull it too quickly, remember, that little click is not a problem. It is a life-saving mechanical warning system doing exactly what it was designed to do. If you have enjoyed learning how everyday technology works, make sure to subscribe to Knowledge Hub for more. And as always, stay curious.